In this video, we are going to convert this polar coordinate. And a polar coordinate, don't forget, is a distance out from the origin on the x-axis and then rotate it around a certain number of degrees. We're going to convert it into a rectangular coordinate, which is more of just your normal x and y, your out a horizontal distance, and then your up a vertical distance. So visually, what we got going on is, let's say we're out a distance of 2. All right, and so we have this circle, which represents this distance of 2, no matter where you're at, and then we roll it up 30 degrees. So we are right here, basically. So that distance is 2, and we're up 30 degrees. So what I instantly want to do is drop a perpendicular down. If I drop a perpendicular down, because I went up 2, I am not out 2 anymore. Okay, I'm maybe pretty close to 2, but the only time that I'd be out a distance of 2 is where I'm at 0 degrees. But as soon as I start kind of rolling onto the circle, I'm not out 2 anymore. So this distance I don't know, the up I don't know, but that's what I'm trying to figure out, because the distance out is legitimately my x, and the distance up is my y, and that's how I could label that coordinate. So I need a visual. We're at a distance of 2. We're up 30 degrees. I'd like to figure out what the x is, and I'd like to figure out what the y is. Okay, so this is very much a SOHCAHTOA thing. All right, so from this angle, this is my opposite. This is my adjacent. And this is the hypotenuse. Okay, so let's say we start with the x, alphabetical. If we're starting with the x, we know this angle, we know the hypotenuse, so we'll have to use both of those. And what we're looking for is the adjacent. So we're talking about these two pieces right here. We don't need to know that or care about that whatsoever. So that's the adjacent and the hypotenuse. And so the adjacent and the hypotenuse refers to a cosine. So I want to set up a cosine equation with this information. So cosine of 30 degrees would equal the adjacent, which we don't know, over the hypotenuse, which is 2. Okay, so cosine of 30 equals the adjacent over the hypotenuse, x over 2. And then we want to solve this equation by taking the 2 and multiplying it over to the other side. And so x is going to equal whatever this turns out to be. And that's going to be 2 cosine 30, 1.7. So that distance is 1.7. So see, it was close to 2, but it can't be 2. All right, so there's our x value. To do our y value, so right now we're sitting with 1.7. I just don't know the up part. So for the up part, this time I'm not going to talk about the x at all, even though I just found it. I don't want to use it just in case I got it wrong. So if I'm talking about the y value, and the other value that I know is the hypotenuse, you're looking at opposite and hypotenuse, which is a sine function. So then I'll set up sine of 30 is going to be the opposite over the hypotenuse. We clear out our fraction by multiplying by 2. And so our y value is going to equal whatever 2 times sine of 30 is. 1. Right? So that is our x and y value. Okay, so let's do one more. If we talk about this one, we're looking at a circle again that is out 7. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 6, 7. 2, 3, 4, 5, 6, 7. So we're looking at a circle. That looks like that. And that pi over 2 is a radian version, which is equivalent to 90 degrees. So if I plot that point like we did here, I am out 7. That's what that tells me. And I am up 90 degrees. That's what the pi over 2 tells me. Well, as a coordinate, I don't really need to do anything. My coordinate is 0, 7. That's my x, that's my y. So when it lands on an axis, the axis is very straightforward. It's just something comma something, like, right? Like it's 0 comma something or something comma 0, just depends on which axis that you line up. But a real quick refresher, remember that if you're in radians, 2 pi is equivalent to 360 degrees. So if you cut that in half, that would be pi is equal to about 180 degrees. Well, it is equivalent to 180 degrees. And then if you cut it in half again, you're looking at 90 degrees. And that's where that comes from. Okay, so we are out a distance of 7, and then we rolled it up 90 degrees. And then this one, we are out a distance of 2, and we rolled it up 30 degrees, which then created a triangle that I used SOHCAHTOA to try to figure out my values. And that's how I got my x and my y. All right, so that was converting polar coordinates into rectangular